So before we begin this next problem, which obviously I've spoiler alerted by putting under the subtitle of tree diagrams, I'd like for you to answer the question, assuming I had given you no spoiler alert, about if I flip a coin 3 times, what's the probability that I get all heads, what's the probability I get 2 tails, and what's the probability I get at least 2 tails. So come up with an answer for those. Again, pretend that you hadn't seen the spoiler alert. What would you have done? So tree diagrams are one way that we can look at solving probability problems to get an idea of just exactly how many outcomes there are. So if I were to flip a coin 3 times, it'd be the same thing as flipping 3 individual coins because they are in fact independent. So for the first coin flip, I would have 2 outcomes. I'd either get heads or tails. As a matter of fact, I could actually write in here the probability for each of those. And then the next event would be I flip again. So off of each of these, here's the second coin flip. Because they're independent, I can get either heads or tails. Again, if I wanted, I could put the probabilities on here. These will be useful to us later. And then the third event is that I flip again, and of course off of each of these I could get another heads or tails, again because of the independence. And then if I look at following every single path all the way out from the very beginning until I get to the end of the path, I can see what the outcomes are. So if I follow this top one, I get heads, heads, heads. The next one, I get heads, heads, tails. The next one, I get heads, tails, heads, heads, tails, tails. Now I'm down on the lower branch, so I started with a tail, and then I followed out with heads, heads. Then I went tails, heads, tails, 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 heads, and tails, tails, tails. So if I look at how many outcomes there are in fact 8. So I have 8 outcomes. Now, because the probability was the same for each branch, I can actually say that the probabilities for these were the same. But if I want to calculate the probabilities on a tree diagram, I simply follow the path and multiply the numbers that I got along that path. So I would have 1/2 to the 3rd power, which in this case is an 1/8. So every single one of these is now 1/8. And if I total all of them up, they do in fact equal 1. And that will be the case for every tree diagram. So now, if I'm looking for all heads, that only happened on the first outcome. If I'm looking for 2 tails, well, I see 2 tails here, and here, and here. Now, that one's a little ambiguous because I don't know if it means at least 2 tails, like the bottom one, or exactly. I'm going to assume this is exact, since I believe that's what I actually intended. Would have been nice if I typed that. And so that one is 3/8. Versus at least 2 means I could have 2 or more, and so therefore I would count the last one, which would be 4/8 or 1/2. So tree diagrams make it very easy to see what's going on with the entire sample space.